Okay, to start chapter 5, we're going to talk about the periodic table. So first off, Mendeleev was the person who first originally discovered there was a pattern to the elements that we have. So that was way back in 1869. When he originally designed the periodic table, he found that there's a pattern with atomic mass. So he arranged them in order of increasing atomic mass from smallest to biggest. But he did find that there were some gaps in there, but they kept that in order because that seemed to be logical at the time. When they had it by increasing mass, you could see that the similar properties that there were between the elements occurred in a repeating pattern. So you may have one that's metallic, one that's non-metallic, one metalloid, and then the repeating pattern starts over. He noticed that, and that's why they called it the periodic table, because periodic means something happening in an interval. So what he found is that it happened every 7 elements when he had this original arrangement of the elements. Fast forward a few decades, in 1914, it was found that when the elements were arranged by atomic number, all those gaps that were there were filled. So instead of by mass, we're now looking at atomic number, which remember is the amount of protons inside of an element. So the periodic law now states that the repeating chemical and physical properties of elements change periodically with the element's atomic numbers. So we find that now that we have arranged by atomic numbers, those gaps are filled in, but we still have that periodic repeating pattern that's more consistent than it was when we were looking at it with atomic mass. So when we read the periodic table, which you've got one in your agenda, I have one to give to you in print. You have one, there's one on the wall, there's one in your book, there's lots of different options. They don't all look exactly the same, but there are some things they have in common. So first off, any vertical column, so we have 18 vertical columns, those are called groups. So we call those the groups on the periodic table. And all the elements within a group have common traits. So for example, group 1, the very first column, they all are super reactive. That's something they all have in common. You'll find that as you go down throughout the other groups, they all have things in common too, which we'll get to when we talk about the specific groups. All the horizontal rows we call periods. So groups are up and down, periods are from side to side. So here's a picture just to show you. I have group pointing to group 15. All of those elements there have traits in common, where the period, we're looking at period 4 there because it's the 4th row down, that they don't necessarily have things in common there, but they're all there. You can see there'd be a pattern if you went through those to see what traits each of them have. All right, so we have something called periodic trends. So as you follow your periodic table, you will find that as you go left to right, up and down, there are different trends that it tends to follow. So first off, atomic radius, which is the measure of the size of the atom. As you go left across the periodic table and you go down, you are going to see an increasing size and atomic radius. So our helium is at the top right, which means it's the smallest radius, and if you go all the way down to the bottom left, because as you go left and down it increases, you have francium, which is our largest radius. So as you go left and you go down, you're going to get your largest radius. Let's go ahead and, in order to get 100% credit for these notes, I want you to write francium and write helium. Just write the words out next to the picture that I gave you so I can know that you were listening. So write francium, F-R-A-N-C-I-U-M, and helium, H-E-L-I-U-M. That way I know you are listening. All right, our next periodic trend is the reactivity. So how reactive something is with other elements. The reactivity of metals, which make up the majority of the periodic table, increase as you go down and left, so similar to our atomic radius, and the reactivity of nonmetals are going to increase as you go up and right. So you can see there in the picture it shows the illustration of the up and down arrow, the left and down arrows, and the up and right, and so they're opposite, but make sure you know which is which there. So for metals, down and left increases. So francium is the most reactive metal, whereas fluorine is the most reactive nonmetal because you're increasing as you go up and right.